This video will explore prompt engineering techniques that unlock smarter, faster, and more accurate responses from AI tools. Prompt engineering is the skill of giving clear and well-structured instructions to AI tools so that you get better, more accurate, and more useful results. Instead of asking vague questions, you guide the AI by providing context, specifying what you want, and sometimes defining the format or style of the response. This helps the AI understand your intent more precisely and produce high-quality outputs that match your needs. Rule 1. AI needs context. AI performs best when you provide clear background information and the goals of the task or project. The more context you give, such as what you are trying to achieve, who it is for, and what outcome you expect, the more accurate and relevant the AI's response will be. A bad prompt like "make a website" idea is too vague, while a good prompt clearly specifies the number of ideas, target level, technologies, and required details like features, difficulty, and skills to make the AI response structured and useful. Prompt engineering focuses on clearly defining the role, who the AI is, the task or goal, what it should do, the context, and the constraints output format to produce more accurate and usable responses. Role prompting is a technique in AI prompt engineering where you assign the model a specific identity or expertise so that it responds with behavior, tone, and knowledge aligned to that role, improving the relevance and quality of its outputs. An example of role prompting is when you explicitly assign the AI a professional identity and ask it to answer from that perspective, such as saying act as a senior AI engineer and explain how an AI agent processes a user prompt, or act as an AI tutor and explain how AI agents read and respond to user input using real-life systems like chatbots and search engines, which guides the model to adjust its tone, depth, and structure of explanation. In this case, the AI would describe how a prompt is first broken into tokens, then interpreted by a transformer model to understand intent and context, how system instructions and conversation history influence the response, and how some agents may call external tools like search engines or APIs when needed. Similar to how a chatbot in customer support understands a question like "where is my order?", identifies it as a tracking request, retrieves data from a back-end system, and then generates a natural language response. While the AI tutor framing would simplify the same process using real-life analogies like a librarian quickly finding and summarizing the most relevant information before responding in a clear and helpful way. An example of role prompting is when you ask an AI to act as a machine learning engineer, a data scientist, a software engineer, or a startup mentor and explain how an AI agent thinks and responds to user prompts, which changes how the model structures its explanation because it tailors the depth, vocabulary, and examples to match the assigned role. For instance, a machine learning engineer would focus on tokenization, embeddings, attention mechanisms, and transformer-based inference to explain how input text is converted into predictions. A data scientist would emphasize statistical learning, pattern recognition, and probability-based outputs learned from large datasets. A software engineer would describe it as a request-response system where a user prompt goes through an API, is processed by back-end services and model inference pipelines, possibly calling tools like search engines or databases before returning a formatted response. And a startup mentor would explain it in product terms as a seamless user experience where complex AI and back-end processes are hidden behind a simple interface that turns user questions into fast, helpful answers, demonstrating how role prompting not only changes what the AI explains, but also how it frames the same underlying system from different professional perspectives. Rule 3. Output format control. In prompt engineering means specifying how the AI's answer should be structured or presented, such as bullet points, tables, steps, JSON, or a paragraph, either before ordering the question so the response comes out in a predictable and usable format. Here are two examples showing Rule 3, output format control in prompt engineering, where you define how the answer should look. Prompt 1. Explain machine learning in bullet points with a simple example response. Machine learning is a type of AI where computers learn patterns from data instead of being explicitly programmed. It uses training data to find relationships and make predictions. For example, a spam email filter learns from thousands of labeled emails, spam versus not spam, and then predicts whether new emails are spam based on learned patterns like keywords or sender behavior. Prompt 2. Compare AI versus ML in a table. Response. Artificial intelligence, AI, is the broader field focused on creating systems that can perform tasks that normally require human intelligence, such as reasoning, perception, and decision-making, while machine learning, ML, is a subset of AI that focuses specifically on systems that learn from data to improve performance over time without being explicitly programmed. AI includes rule-based systems, robotics, and ML, whereas ML specifically includes models like regression, decision trees, and neural networks. In terms of scope, AI is the umbrella concept and ML is one approach within it. For example, a chatbot is AI, but the model that learns from conversation data inside it is ML. The key focus of output format control in prompt engineering is to clearly define the structure, length, style, and format of the AI's response so that the output is immediately usable without needing extra editing or reformatting. By explicitly telling the model how the answer should look, such as in bullet points, tables, numbered steps, JSON format, or a detailed paragraph, you guide not only what information is included but also how it is organized and presented, which greatly improves clarity, consistency, and efficiency, especially in real-world use cases like writing reports, summarizing documents, creating study notes, generating code, or preparing presentation content. Additionally, controlling the tone, formal, simple, technical, length, short, medium, or detailed, and level of detail ensures the response matches the user's exact need, reduces ambiguity, and makes the AI output more predictable and ready to use instantly in practical workflows without further rewriting. Rule 4. Critique and improve. In prompt engineering is when you instruct the AI to not only give an initial answer, but also evaluate its own response, identify weaknesses, and then improve or refine it, which leads to higher quality outputs because the model can correct missing details, unclear explanations, or weak structure. Instead of producing just one static answer, the AI first generates a response, then critiques it for accuracy, clarity, completeness, and relevance, and finally produces an upgraded version, making the result more reliable and polished. For example, it might first explain machine learning in simple terms, then notice it was too vague or lacked examples, and then rewrite it with clearer definitions, step-by-step logic, and a real-life example like spam email detection, ultimately improving both depth and usability of the final output. In prompt engineering, a critique and improve loop, Rule 4, means the AI doesn't just give one answer, but first reviews its own output and then upgrades it for clarity, completeness, and usefulness. For example, if the prompt is "give me website ideas for beginners," the AI might first respond with simple ideas like a blog, portfolio website, or online store, but then it critiques that response by checking what's missing, such as organization, usefulness for beginners, and missing categories like tools or difficulty level. What works, it is simple and relevant, and how it can be improved, add structure, examples, and clearer guidance, and then rewrites a better version that could group ideas by purpose, like personal websites, blog, portfolio, business websites, online store, landing page, and learning projects, simple HTML practice sites, making the final output more structured, practical, and beginner-friendly, which shows how the AI can refine its own reasoning instead of giving only a single static answer. It actively evaluates its own response and then refine it, which improves both the quality of information and the reasoning structure. The key focus is on identifying strengths, gaps, and improvements, where the AI first generates an initial response, then analyzes what works well, for example, clarity, relevance, or correct ideas, what is missing, such as depth, examples, structure, or clarity, and what is weak or confusing, like vague explanations or poor organization, and finally produces an upgraded version that fixes those issues. If the prompt is "suggest ways to improve productivity for students," the AI might first give a basic list like using a timetable, avoiding distractions, and studying regularly. Then in the critique step, it evaluates that the strengths are general usefulness and relevance, but the gaps include lack of actionable detail, no prioritization, and no real-life application strategies. After that, it improves the response by organizing it into clear categories such as time management, using time blocking schedules and setting daily goals, focus improvement, using the Pomodoro technique and removing phone distractions, and study efficiency, active recall, spaced repetition, and practice testing, while also adding simple explanations of how each method works in real life. making the final answer more structured, practical, and easier for students to apply immediately. This course explored prompt engineering, which covered the core rules of effective prompt design, including defining roles, setting clear tasks and goals, adding context, controlling output format, and using critique and improve techniques to refine responses. Through these concepts, you learned how to guide AI systems to produce more structured, accurate, and usable outputs by clearly communicating what you want, how you want it presented, and how it should be improved, ultimately giving you the ability to design prompts that consistently generate high-quality results across different use cases like learning, writing, coding, and problem solving.